Question number 8, in which first part you have to do yourself, second part I am telling you. Okay, so let us start the second part. In second part it is given, if p equals to minus 10, find the value of this. So this expression is given, minus 100. Yeah, it is right. So p square minus 2p minus 100 is a given expression in which you have to find the value after putting p equals to minus 10. So let us write the expression first. Now putting p equals to minus 10, we get, what we will get here by putting it, let us put minus 10 whole square. In place of p we have put minus 10, minus 2 into minus 10, then minus 100. Right? So now minus 10 square. Minus 10 square means 2 times minus 10 multiplied by minus 10, so it will become 100. Okay? So minus 2 minus 10, it will become plus 20. Here minus 100. So this plus 100 and minus 100 will become 0. So answer is 20. So this will be the answer of 8th question, second part. Now let us move to next question, that is question number 9. What should be the value of a? You know, this expression is given and we need to find the value of a, means what will be the value of the variable a, but the two variables are here, x and a. So without knowing the value of x, we cannot find a variable, so which is given when x equals to 0, and this expression is given equal to 5. Means, let me repeat the question, what should be the value of a if the value of this equals to 5 when x equals to 0? Means what is given? This is given that this expression is equals to 5. This becomes an equation. Now this is given, even we can write it is given. Now at x equals to 0, we need to find the value of a. Means we need to put the x equals to 0 here. So let us put 2 into 0 square. In place of x, everywhere I am putting 0. So this. Okay. Now here is equals to sign, so we cannot put the equal to sign here. This sign 2 equal 1 equal to sign and then an arrow. This shows it implies, means what comes after this equation. So that we need to put. Okay. So 2 0 square. 2 0 square means 0. So 2 into 0 it basically comes. So it will become 0 only afterwards. So this is already vanished. Now minus a equal to 5. So it will also become 0. So 0 minus a equal to 5. And then minus a equals to 5. Now minus a equals to 5, and if we transpose this minus a to that side and this will come this side, means after solving the result become a equals to minus 5. So in this way you have solved question number 9. And here is one more question left of exercise 12.3, that is question number 10, but that you have to do yourself. So that's all for 12.3. Some formulas and rules using algebraic expressions. In class 6 you were not very much aware about algebraic expressions, but then also we have done some formulas. Now let us revise some of those, and some are different. First is parameter of equilateral triangle. You know, equilateral triangle means all the sides equal. So what can be the parameter? Means you can add all three sides. So suppose one side is L, so all three are L. Fine. So what can be the parameter? Means after adding 3. So the answer is 3L. You can see here 3 is the constant, L is the variable. That after, if somebody will give us the variable value, then we can solve. Means we can find the parameter of equilateral triangle. So in this also we have used the variables and constants, and we are using algebraic expression. So in this manner we can write. Now parameter of square, in similar terms, what can we write about the parameter of square? Square means all four sides equal. So if one side is L, what can be the parameter? It will be 4L. Now parameter of regular pentagon. Regular pentagon means all sides of pentagon, 5 sides are equal. So here we can write, as the sides are 5, all are equal. If one is L, so the answer is 5L. So we can write in this manner. Now next is area of square. Suppose the square is given and one side is again suppose S is given this time, not L, and one side is S, we need to find out the area. So what should be the area? And we used to write S into S. Basically it is S square, side square. Okay. Area of rectangle that we used to write length into breadth. Suppose this is the rectangle. So this is length and this is breadth. So means L into B. So answer is LB. So you can see we are using the variables here. Area of triangle that you have not done in class 6, but I am telling you what is the formula. Suppose any of the triangles is given. It's not equilateral, any triangle. So there is a height H, means this is a perpendicular from the above vertex to the base. So this is known as H, and this is base, which is the floor basically. So what is the formula? Half into base into height. So we can write B into H by 2 or BH by 2 directly. So here also we are using variables and constants to write the formulas. Now next is a rule basically. If n is a natural number, suppose you have any natural number, you can think of any natural number, suppose 5. So what can be the successor of 5? The successor of 5 is always, if we add 1 into that, means 6. So what you have done, if 5 is the natural number, you have added 1 to it, means 5 plus 1. So if n is the natural number, how we can write it in algebraic form? So it will be n plus 1. So this you need to understand. Now next is, if n equals to the natural number, then how can you write any even number? Just think of any natural number, suppose 3. Okay, so 3 is a natural number. So 3 is not even. To make it even, what we can do? If we multiply it with 2, for sure it will come an even number. 3 into 2 is always 6. So we can write, if n is natural number, then if we multiply it with 2, then always it will become a even number. And you know that after even number always comes as a odd number. So in this algebraic form, if we want to write the odd number, how can we write this? If this is even, so we can add 1. Even we can subtract 1. So that will also be right, 2n minus 1. Okay, so in this manner you can write these rules. Now on page number 244, 245 and in the first half of 246, there are some important things. So don't forget to read these pages. You have to read these pages carefully. 244, 245 and 246. Do this is also given on page number 244. So remember to do this, and you can use matchsticks as well to do the things here, and then you will definitely enjoy this. After this we are going to start exercise 12.4. So in 12.4, question number 1. Now in this question the different patterns are given. There are 3 parts A, B, C. I am telling you the first part. So on the similar lines you can do the next 2 parts. It's very easy. In last year, means when you were in class 6, then you have done these different kind of patterns, in which we have come to know that how we can express these patterns. And here the expression is already given in the question even. You can see for this 6 you can use to find these kind of numbers in the digital clock or the calculators. So how many the sticks are using here? 1, 2, 3, 4, 5, 6. It's already given that we have used 6. To join the 2 6s together, it will become 11 sticks you need. Here 16, next 21, all things are given. So in general, if we solve it, the 5n plus 1 sticks we need. So n, if we put 1n, if we put n equals to 1, so you can solve it. 5 into 1 plus 1 means 5 plus 1, that is 6. So if we put the values 1, 2, 3, we'll definitely 1 means and 1 means 1 6. Okay, so we'll find the same result. So what we need to do in this question is, if the number of digits forms is taken to be n, the number of segments required to form n digits is given by the algebraic expression appearing on the right of each pattern, which is given here. how many segments are required to form 5, 10 and 100 digits. Now we need to find the 5, 10 and for 100 digits. So for 5 digits means for 5 these 6s, what we need to do? We need to put, in place of n, we need to put the value 5. So for 5 this, we put n equals to 5 in 5n plus 1. We will put the value 5 here. So let us put 5n plus 1 equals to 5 into 5, or you can put the brackets as well. Then it will become 25 plus 1. The answer is 26. So how many segments we need for this? We need total 26 segments. So next in the question is asked about 10 these 6s we need to form. Okay, so for 10 these we need to put 10. So for 10, what we need to do for 10? So 5n plus 1, we will put 10 here. Okay, then 5 into 10 plus 1 means it will become 50 plus 1. So the answer is 51. So the different segments we need is 51 to form 10 these type of digits. Okay, so for 10 these digits we need 51 different segments. Now next is given in your book to ask for 100. That is, how many segments are required to form 100 digits of this kind. So 400, just put again in place of n, put 100. It is nothing but 5 into 100 plus 1. So it is 500 plus 1. So after solving 501, it means we need 501 total segments to form these 100 digits of 6. So this is question 1 of exercise 12.4. Now in 12.4 there is one more question, question number 2, in which a table is given in your book. You can see on page number 247 a table is given. So for in this table expressions are given, total 5 expressions, and here the terms are written 1 second, first, second, third, fourth, fifth, 10th and 100. So you need to find out the terms in similar manner. Suppose 2n minus 1 is given here. Okay, 2n minus 1. 2n minus 1 is given and you need to find its 100th term. So again here you can put the value 100 in place of 1. So after solving it, 200 minus 1 means 199 will be the answer. Then you can write directly in the book itself. This question you can do in book by solving it in rough and write the answers in book as this table is given here. Fine. All the parts you have to do and all the parts you write in book only. So thank you so much.